So assignment related to standing waves. So we'll discuss mainly the questions related to standing waves. Some of the question might be there from interference, but because we did not complete that topic yet, so we will skip. Right now we'll skip, and later after completing a topic, we will do interference questions as well. Yesterday. So only questions related to standing wave. This is about interference. This was the last question I guess we discussed yesterday. Okay. In question 7, a musical instrument you can see on your screen now. So with the mouthpiece at one end as shown, the mouthpiece is there and open E is there and it refers. When a musician blow into the mouthpiece, a standing wave is produced because as we discussed yesterday, for a standing, when we have open pipe, always at the open end there will be antinode and in the center, not always in the center, but if it is in the first harmonic or the fundamental frequency, the antinodes are always at the end and node will be there at the center. So standing wave has antinode at both ends of ear column as shown in the figure. Calculate the frequency of a sound produced by this standing wave. The speed of a sound is there, the length of a recorder. So using a length, first we have to determine the wavelength. So the total length is L example, which is 23.6 centimeter. So this is antinode, node, and antinode. And we have discussed the distance between the two successive nodes or two successive antinodes. That distance is half of wavelength. So basically, this length is how much? It is half of wavelength. So we can say L is equals to lambda by 2, or 2L, the twice of the length will be equal to lambda. So basically the wavelength is twice of this. So if the length is 23.6 centimeter, the wavelength will be twice of this, so it will be 47.2 centimeter. But so this is 2 into 23.6, that make 47.2, but in centimeter we need in meter, so we'll divide by 100, so we'll get this in meter. So the wavelength will come out as 0.472 meters. Then we have the formula V is equals to F lambda. So speed is frequency multiplied by wavelength. What about the speed? It is given 330. Frequency is unknown and the wavelength of the wave, that is 0.472. So this is multiplied, other side will divide, so it will be 330 divided by 0.472. This will give us the frequency of this. So it will come out around 699 hertz. That's a fundamental frequency. Is it clear? The first part. Then the second part. The recorder is made from 3 separate sections that slide into each other. The musician play the recorder and produce the same frequency as in A1. So like examples, he want to produce the same frequency, he want to produce 699 hertz. But this time, by changing the length like he changed the length of the musical instrument, the temperature of the air increase. As the temperature of the air increase, the speed of a sound will also increase. Explain how the musician can adjust the recorder to produce the same frequency. So how a musician can adjust a recorder to produce the same frequency? Look, we have the formula V is equals to F lambda. And we work out that lambda or wavelength is equals to 2L according to when it is vibrating in the one loop. So V divided by 2L is equals to F. So what is happening? Because as the temperature increases, speed is increased. We want the same answer for frequency. We don't want the frequency to change. So what 2 cannot be changed. So what we should do, we should increase the length of this recorder. So to keep the same frequency, we should increase the length, because when we increase, as the speed is increasing, the length should also increase. So the ratio between the speed and the length refers to frequency. So what a musician can do, he can just sliding the recorder section further apart. For example, increasing the length of this recorder. If you want to produce the same frequency of 699 hertz, this was the original figure. As you can see, this was the original, but as I mentioned, these parts can slide. Like we can change the length, we can either reduce the length or we can increase the length. So what we should do to this, we should increase the length or we should slide the parts away. If the temperature increases, the speed of the wave also increase. So we should slide these parts away and use a longer apparatus to keep the frequency same. Is it clear, this part? That what we should do to these parts if we want to produce the same frequency as the temperature of the air has changed. The next one, in a violin, a stationary wave is created when a string is plucked, and a violin string has a fixed length but tension can be adjusted. When a string is plucked, it produces a sound of frequency 432 Hz. The string adjusted to produce a frequency of 440. Calculate the percentage increase in the tension, like how we are changing the frequency and they're asking what should be the percentage increase in the tension. So how we can work out this? First we have to use a formula. Wave, the speed of the wave in a string is given by a formula V is equals to under root T divided by mu, and speed of the wave is given by a formula V is equals to F lambda. So when we compare these two equations, we can say that frequency into wavelength is equals to under root T divided by mu. So wavelength, we just want to change the frequency. So what is the relay, or we want to change, we change the frequency. So what tension should be there? If we keep the wavelength same, or we can substitute this value, like wavelength, we are not changing the wavelength, we are not changing the thickness of the string. So we can say that frequency is directly proportional to under root of tension, because both are in numerator. If other parameter does not change, so frequency is directly proportional to under root tension. Or if we square this, so we can say frequency square is directly proportional to T. So frequency square is directly proportional to T. Whenever two quantities are directly proportional, we can use a constant equal to and constant. So we can say K and T. Or we can say F square over T is equals to K. So the frequency has changed, the tension will also change. So we can say F1 square over T1 is equals to F2 square over T2. Like the first frequency square divided by original tension equal to the second frequency square multiplied by the second value of the tension. So when we simplify this equation, we can say T2 divided by T1 is equals to F2 square divided by F1 square. And what is F2? The second frequency is 440 square and the first frequency is 432 square. So 440 square divided by 432 square. When we simplify this, we'll get 1.03. So the ratio has changed, like this is 1.03. What does it mean in terms of increase? So if this ratio was 1, it means there was no change. But if we are getting 1.03, so this, if we convert into percentage, it means how much it increased. It increased by a factor because of 0.037. Because if the two frequencies were same, this value will be 1. But if frequencies change, this value is 1.037. So how much the increase in the value or change in value is? It's 0.037. And in terms of percentage, how we can represent 0.037 in percentage? So 0.037 multiplied by 100 to get in percentage. So it will come out as 3.7%. So 3.7% is an increase in the tension compared to the original value. Is it clear? That how we work out. So for these two formulas are important. V is equals to under root T divided by mu and V is equals to F lambda. When we compare the two equations, we can say F lambda is under root T divided by mu, or we can say, because the lambda is not in the question, they did not mention anything about the lambda or about mu. So we are just finding a relation between frequency and the tension, so they are directly proportional with a rule. So we can say square, so F frequency square is proportional to T, or F1 squared by T1 is equals to F2 square over T2. Then we are finding a ratio between T1 and T2. So if the ratio between T1 and T2 is 1.037, originally it should be 1, because if it does not change, ratio will be 1. It changes, it is 1.037. So how much there is a change in the ratio? That is 0.037 or 3.7%. In question 8, in a piano, a note is produced by striking a stretch wire with a hammer. Which of the following describe a wave produced in a wire? So the wave, because the wave which is produced in a wire, that is a standing wave, and that is standing wave in that sense, it does not travel from one place to another, it is in the confined region. And because a particle vibrates perpendicular to direction of the energy transfer, so we can say that it is transverse as well. So it is transverse and stationary or standing wave. Because it wave in a string is a transverse wave. If it was a sound wave, like example, the same question was there and they say a musical instrument or a pipe which produce a standing wave inside the pipe produce nodes and antinodes. And they ask what is the nature. So in that case, what should be the answer? It should be longitudinal, because in sound wave the particle vibrate parallel, and it is stationary. Why? Or standing wave, because it does not travel from one place to another. But in this case, because it is a string or a wire, so it will always be a transverse wave. The wavelength of a progressive wave is defined as distance between. Progressive wave means a wave which travel from one place to another, that we called as a progressive wave. So how we define the term as a wavelength? Wavelength is the distance between the points which are in phase. Like with a crest, point at a crest and another crest, so these points are in phase. a point at a trough and a trough. These points are in phase, so we call that distance as wavelength. So the points which are in phase, we can refer them as wavelength. In question 10, frequency is 160 hertz and the speed is 340. Which of the expression gives a phase difference in radian between 2 points which are wavelengths of 1 meter apart? First thing, what is the relation between the wavelength? When one wavelength is there, what will be the phase difference? That is 2 pi radian. So one wavelength or one lambda is equals to 2 pi radian. Now first we have to work out the wavelength here. So one wavelength is 2 pi radian. Now what is the wavelength of this wave? So how to know the wavelength? Wavelength is speed divided by frequency. So speed is 340 and the frequency is 160 hertz. So it means one wavelength, in this example, one wavelength is 340 divided by 160. So 340 divided by 160 I can write here. So 340 divided by 160 is equals to 2 pi radian. Or 340 divided, because they did not solve in the option, they did not solve, that's why I'm not solving into decimal. I just write 340 by 160. It's 2 pi radian. If we have 1 meter apart, a wavelength 1 meter apart, so it will be x radian. So we cross multiply. So 1 will be multiplied with, so it will be 340 divided by 160 into x is equals to 2 pi. Or x is equals to 2 pi multiplied by 160 divided by 340. So 2 pi multiplied by 160 divided by 340. So C will be the right answer. Is it clear, this one? Question 10. Then this is related to interference, as we are only doing this the transverse this standing wave question. Two loudspeakers produce identical sound of frequency 440 which superimposed produce a standing wave. The adjacent nodes are 0.75 meter apart. Select a correct statement. So if adjacent nodes, like example, this node is the minimum displacement position, or points are known as nodes. So this is node, node and antinode. So distance between the two successive node, so that is lambda by 2 is equals to 0.75 meter apart. So lambda is multiplied here, so it will be 1.5 meter. So wavelength of this wave will be equal to 1.5 meter. Frequency heard 880, no, they already mentioned the frequency is 440, so we don't hear that. Speed, how to know the speed? So speed is frequency times the wavelength. The frequency will be 440 times the wavelength is 1.5, so 440 times 1.5 is not 165. The waves are traveling in the same direction. The waves are not traveling in the same direction, they are traveling in opposite direction. That's why two waves which are traveling in opposite direction give rise to a standing wave. This is interference. So standing wave produced by interference, two coherent waves emitted which are in phase. Two waves meet at a point, have traveled slightly different distance. The wave now have a phase difference of 180. So whenever phase difference of 180, which of the following could be a part difference? So what is the relation between the part difference and the phase difference? When the part difference is 1 wavelength, the phase difference will be 2 pi. So if the phase difference is pi, then the part difference will be x, cross multiply. So it will be lambda by 2. That's why B will be the right answer for question number 14. So this is a relation between a part difference and the phase difference. If part difference is 1 wavelength, phase difference will be 2 pi radian. So standing wave is there, which is a correct relation between the part difference and the phase difference. So when the part difference is half wavelength, phase difference will be pi. Like this will be a destructive interference, or it will be a formation of a node. And when part difference is lambda, the phase difference should be 2 pi radian. This question 16 is about the interference. A longitudinal wave moving along a spring, 2 points on a spring are separated by half wavelength. So if they're half wavelength, means the phase difference will be pi, or there will be 180 out of phase. So what will happen to the particles which are lambda or 180 or pi in terms of phase difference? So they will move in opposite direction. Which of the following is a standing wave? Standing wave means wave which is confined within the region. We call that as a standing wave. Light emitted as a line spectrum, wrong. Ripple of water thrown, so they travel, they don't sound from opera singer in a theater. It is actually traveling from one place, a progressive wave. But vibration of a violin string which is played, because strings of the pipe instrument, they produce a standing wave which enhance the sound. So that's why D is the right answer. The graph is there for a displacement and time. So X is already started here for question 19. X is already, because when time interval, this time is 0. So but X is already have some vibration, which means X is already started. So X is ahead, X is started first. So we say X is ahead. So either C will be answer or D. But D cannot be, because in D they say Y is ahead. Then, and how much X is already completed its motion, because that's a quarter of a wavelength. As we know, one wavelength is 2 pi radian. Then half of wavelength will be pi radian, and quarter of the wavelength will be pi by 2 radian. So it is quarter of the wave or the pi by 2 radian ahead. Means X has already completed 90 degrees of pi by 2 radian before Y. Whenever it's a time axis, remember the wave which already started its vibration is ahead. But if it was the same question was there, the displacement axis, and in that case, because both waves should start from the same point, so same mode of vibration for a displacement. So this is not considered for X, and this will be the considered for X. So it means in that case the Y will be ahead. So the diagram shows a standing wave. As you can see, we have what is the phase difference of a progressive wave? Progressive wave means the two waves which combine. This is the result which we see. The result of the two waves. So at X it's a node, and at Y it is an antinode. So when node is formed by a constructive interference, so constructive interference, the phase difference should be 2 pi, or the part difference should be lambda. Sorry, its node is there. So whenever node is formed, they should completely cancel out the effect of each other. So destructive interference, so this will be pi or lambda by 2. And when antinode is formed, so X is at node, so it will be pi or lambda by 2, but they're asking for phase difference. and y is the antinode, so it will be 2 pi or lambda. So for x, because it's a node, the two progressive waves cancel out the effect of each other and the result is a node. And two progressive waves increase the effect of each other and result is antinode. That's why B is the right answer. The diagram represents the standing wave. Which diagram correctly shows the position of node and antinode? So this is wrong because no, this is not antinode. This is node is correct, antinode is wrong. Node is correct, and node is correct. So C here totally wrong. So C is the right answer. The diagram represents a standing wave. The length of the string is 4 meter. What is the wavelength? So it is two loops, but two loops. This is node, node, and node, and the distance between the three successive node is equals to wavelength. So actually, the length is all of the string is equal to wavelength. So if the length is 4 meter, the wavelength is also 4 meters. If this was only half of it, like example, they say only this part was given or shown, then what we can say length is equals to lambda by 2 or lambda is 2L. In that case, it will be 2 multiplied by 4, which is equals to 8. In that case, D will be the answer, but the original question, it is one complete wavelength as 3 successive nodes are there. This question is the previous question. This one is about two speakers connected produce sound wave. Yeah, this is about interference. Standing waves are created in a pipe of length L and it's a close at one end. There's a node at the open end and antinode at the close end. Means this is a pattern of the vibration. Antinode is there and node. So the distance between the node and antinode is equals to quarter of the wavelength. So L is equals to lambda by 4 or wavelength is equals to 4L. So what is the wavelength correspond to the lowest possible frequency? The wavelength is equals to 4 times the length or 4L. So a student draws a pattern formed for a standing wave is determine the wavelength. How we can determine the wavelength? So this is node, 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 and node. So from 3 successive node it is 1 wavelength and 2 successive node it is half wavelength. So 1 wavelength plus half wavelength it is 1.5 wavelength or 3 by 2 wavelengths is equals to 96 centimeter or wavelength is 96 times 2 divided by 3. So this will give us the wavelength of this standing wave, which is 64 centimeter. Then the 2 points on the adjacent antinodes, like this is antinode, this is also antinode. So these particles, W is trying to move down, X is trying to move up. So what is the phase difference between them as they're vibrating in a different pattern or manner? So the phase difference will be 180 degrees. So this will be 180. Describe how standing wave is formed. Always, this is a very common question. So what should be your answer? And it should be in with the specific terms you should use, like you will mention two progressive wave. Progressive means a wave which can travel from one place to another. So two progressive wave traveling in opposite direction. That is also the thing. If you say don't mention they are moving in opposite direction, it won't be correct. Then what they do, they superimpose or interfere or combine or superimpose. And then what happen? Produce nodes region of destructive interference. Destructive interference means where they try to cancel out the effect of each other. And produce antinodes region of constructive interference. So this is always the answer whenever they ask how the standing waves are produced. So this was exercise related to topic standing waves. Any question or doubt related to the class?